go ahead with the virtual tour, and I'm going to go ahead and end the poll. So thank you for participating in the poll. Only 52 of you guys have done it. Now that's only 61% have voted. So maybe you can get your last few votes in.
All right, sure. Thank you. So I'm here with two other colleagues. I'll just want them to introduce themselves to tell us what they work on at Zipline before we go ahead with the tour. So we can start with Vasu.
Hi, everyone. My name is Vasu. I am an engineer working on our behaviors team at Zipline. So I'm responsible for vehicle behavior, specifically in response to any other aircraft that we might detect.
All right.
It's great to be here. Thanks for having us.
All right, Divya.
Hi, I'm Divya. I also work on the behaviors team with Vasu. I work on algorithms that help the drones avoid each other in air. And yeah, I'm super happy to be here as well. Thanks for having me.
All right, thank you. So we are currently at Zipline's distribution center in Ghana, the third Zipline distribution center in Ghana. The tour will be in two phases. We're going to give you a tour of the fulfillment warehouse, then finally how the drones are sent out of the distribution center. I'm going to switch my camera so you see what's happening on the background. So this is the entrance to the fulfillment warehouse. Mind you, at any point in the tour, if you have questions, Vasu or Divya can just hop in and answer the questions that you may have. So we're going straight into the warehouse. Okay. So just as I mentioned, this is the third Zipline distribution center. Zipline has 4 distribution centers in Ghana. They are different parts of the country. This one currently is in the northern part of Ghana. This distribution center serves about 260 to 300 health facilities, ranging from the lowest level of health facilities that we have, which are the CHIP compounds, to health centers, to district hospitals, to regional hospitals as well. So we serve these group of clients. This is the fulfillment warehouse where we store medical products, the vaccines, and the blood products that we send out to the health facilities that we work with. When the COVID pandemic started as well, the government of Ghana tasked us with sending out personal protective equipment and also COVID samples to testing labs in Ghana. So we are going straight into how we manage inventory here and how the products end up on the shelf as you see them. I'll dive a little into our upstream suppliers that bring us the products. This is our staging area or our transition area where our upstream suppliers give us products from. So when the products arrive at the distribution center, we keep the products here for some time. When the products get here, we do a head count to make sure that the products correlate to what we have on the invoices. Then we also make sure that we dust the products off any particles before we finally bring them into the warehouse. When the products get into the warehouse, we do something we call a visual or physical inspection. And what this does is to make sure that we check for quality standards and any defects that may be on the product. So using this product as an example, we see that we have a Zipline ID on the product. It's an alphanumeric number that uniquely identifies this product. So after the visual inspection, when we notice that, or when we make sure that this product passes the quality standards or the quality processes that we have here, we receive it into Zipline inventory. So when the receiving is done, we assign the ID as you see it here, the barcode that you see on the product. So every product you find on the shelf has this barcode, and we use that in inventory management and also to track how products are sent out of the warehouse and how products are accepted into the warehouse. The next thing that we want to talk about is how we receive our orders from the health facilities that we work with. We currently communicate with our healthcare facilities using 3 main methods. This is the fulfillment system that we use in-house. It displays how we receive orders, how orders are packed, how inventory is managed as well. The facilities reach out to us using 3 main methods: the phone call, the WhatsApp message, and the text message. So any facility that wants a product from Zipline reaches out to us using these 3 methods. The next thing that we enter into the system is the type of order. The doctor or the pharmacist that is making the request is also selected. Then the next thing that goes on is the type of request. Currently at Zipline, we have 3 types of requests. We have emergency requests, just as the name suggests. These are requests that are made when facilities have need of the product immediately. So maybe a kid is bitten by a dog and we go to the health facility and we need anti-rabies. That is an emergency. For resupply orders, these are orders that are done when facilities want to buffer their stock or want to keep a minimum stock level of a particular product in their facility. Then finally, we have scheduled deliveries. And these deliveries are deliveries that facilities make when they need the product at a particular time. So they communicate that time and date to us. Then we schedule the deliveries to be made on that date. The final thing that is entered into the system is the product that is being requested for. So depending on the type of product, whether it's paracetamol, the quantity of the product, and we enter this into the system. When this is done, or when this order is submitted, the order moves from the order taking interface to the packaging interface where the products can be packed and sent out to the health facilities that ordered them. I don't know if there are any questions. Okay, so there are no questions in the Q&A so far. So I'm going to go ahead and to show you how the packaging is done here in the warehouse. So we have a pharmacist here. He's a fulfillment operator as well. He's going to help us with how the packing of the product is done at the Zipline warehouse. So just a little detail about the box that we use in packaging. So this is the box that is used in packaging. It has 3 main components. The box is made up of the air inset. This is a material, it's like a balloon that helps with buoyancy and also impact when the package falls. Then the parachute of the box has a parachute. This is how the parachute looks like. The parachute is what helps with landing. It would interest you to note that our drones don't land. So these are some of the systems that we put in place to make sure that the packages are intact and the contents are intact when they get to the health facility. So this is how the box looks like. The final component of the box is the red patch you see, which is made up of biodegradable paper. So this is the box that the packages go into. One key thing that you should note is that our packages work with a payload. There's a particular payload that it needs to be able to fall within the optimum range. And currently the payload that we use is 1.2 to 2 kg. That's the weight of the products that can go into the box, or the total weight of the products that can go into the box. The packaging is finally done using Dunnage. It's an insulating paper. This is how it looks like. The brown paper you see down there, because of the material that is used, the lattice formation as well helps with product impact and also make sure that the quality or the product doesn't get destroyed before it gets to the health facility. So these are some of the systems that we put in place to make sure that when the products drop from that high distance from the sky, the contents in the product, the contents in the box is still intact. Let me give you a classic example of some of the fragility of the products that we work with here. So this is oxytocin, one of the products that we send out. And I want to show you how the ampule looks like. So this is how the ampule looks like. It's a very fragile product, and it's very important for us to make sure that the contents in the box are intact when they get to the health facilities that we serve. Moving on, we'll leave the fulfillment operator to package the product. Then we go on to see some of the equipment that we have here that store certain products that we have. So moving on, we have some cooling devices here. The first one is the vaccine fridge that houses the vaccines that we send out to the health facilities. Then we have blood fridges as well that store blood products and other blood components. We have freezers as well that store other blood components. The facilities that we have here do not have access to these equipment. So they rely on the Zipline service to provide them with all the logistics when it comes to storage as well, because here at Zipline, at the distribution center, we have 24/7 power that is able to keep these products in their optimum temperature ranges to make sure that the products are still in good condition. So these are some of the storage facilities that we have here. I would pause for any questions, if there are any, before we move on to the flight operations area to see how the packages are sent out to the health facilities. Are there any questions so far?
Do you only have one size package, or are there different size packages?
No, currently we have just one size package. This is how it looks like, the package I just showed. So the packages are just one size, but the products that we put in the packages vary. And for when we get a product that doesn't meet up the payload range, we use something we call water ballast. These are just Ziploc bags that have been filled with water, pre-filled with water according to certain weight ranges. So we use that to complement for the extra weight that we need to make up the payload. Yeah. Any other questions, please, before we move to the flight operations area?
We do have a question. One of the questions in the question and answer area asks, how many deliveries a day for Zipline? All of this is so great.
All right. Let me talk from this distribution center. So this distribution center currently records about an average of 100 deliveries in a day. And our peak day delivery so far has been 152 deliveries in a day. For weekly stats, we do about 1,800 deliveries across all distribution centers in Ghana.
And we have another question. Is the drop area large, or are there any misdrops, and how is that type of thing handled?
Okay, the best word that he used was drop area, which is right. So we don't have this specific point that the product drops. It's an area plus or minus, and this has been preloaded in the battery of the drone. So the drone knows exactly where it's going to drop the package when it gets to the hot facility. So it's a whole range, about 2 meters range where where the package can be dropped. So depending on the drop area or the wind direction, when the drone gets to the facility, it can drop plus or minus of that range. I don't know if that answers the question.
I think that probably does answer the question. We have another one. What is the furthest range that your drones can travel?
Okay, currently from a particular distribution center, we travel about 85-kilometer radius in a straight line. So if the distribution center is centered in a straight line around like a circumference, 85-kilometer radius. Yeah.
And thank you.
All
That
right.
seems to be the last question.
All right, sure. So we're going ahead to the flight operations area to see how the packages are sent out to the health facilities that we work with. I'm sure Vasu and Divya can go into certain details if you have anything to add before we finally go to the flight operations area.
No, you're doing a really good job. I think one more question came in, which is what happens when a drone goes down while on a mission?
Goes down. That's it would have to be explained. Goes down how?
Yeah, that's all the question says. Do you want to talk?
It fails in its mission, I think.
Falls to the ground.
Okay.
Do you want to just explain how our zips fail?
Vasu, you were saying something. I didn't quite get it.
Do you want to just explain how our zips execute a flight failure?
Oh, okay, all right. The drones are fully automated, and they don't. There's no pilot controlling the drone when it leaves the distribution center. However, there are very few commands that we can give the drones when we are at the distribution center. Sometimes when the drone is in flight, there are very terrible or very bad weather conditions that they may meet, like very high winds. And the drone tries as much as it can to maneuver its way to get to the drop site or get to the distribution center. When we notice that these weather conditions are very adverse, we can give a command for the drone to paraland. It is purely a safety feature that we use here from Zipline or the distribution center. This allows the drone to land using its parachute that is internally built. So this is quite like a safety feature and not, yeah, more likely like a safety feature, yeah. So
I'll add one thing.
All right, sure.
Sorry, I'll add one thing, which is that we also have various checks in place in software, so that if the zip gets pushed too far off its path due to wind conditions, or maybe due to a faulty motor or something like that, it will also autonomously fail and execute that same paraland safety behavior.
All right, sure.
So it's
yeah,
when it gets into a lot of trouble, it'll just deploy a parachute and fall to the ground?
Yeah, gently to the ground.
That's correct.
Can you figure out where it is and recover it?
Yes, because we have the GPS that helps with the location, so we know exactly where it falls when that happens. All right. So we're going ahead to the flight operations area. This is how the area looks like. The current generation of drones that we have 4 components. The first component is the wing that you see here. It spans about 3.3 meters in length. Then we have the batteries. This is how the batteries look like. They are made up of lithium ion. They are lithium ion batteries. And the blinking lights you see here are batteries that are still charging. And the more static blue lights you see are batteries that are fully charged. The batteries are sitting on smart chargers, and the smart chargers do 2 things. The first is to charge the batteries, obviously, and the second one is to help upload flight data that is collected during the flight. And this is the data that helps our software engineers better plan software updates and also other releases as well. So this is the second component of the drone. The third component of the drone, sorry, is the body of the drone. As you can see, we have quite a number of drones here, bodies here. So just go straight into one. This is the compartment where the package sits. So we have the package sitting, these are ejector bands. So the package presses against these bands, and we have a small clip here that holds the parachute. The whole idea behind this simple apparatus is the fact that we want the box to drop first when it gets to the drop area. So the box falls first, followed by the parachute that is held in the clip, so that the parachute can open up gently and collect air to drop in a very gentle and controlled manner. So that's how the principle works here. The final component, which is the 4th component, is the nose foam of the drone. This is how it looks like. We are going to see shortly how the drone is assembled onto the launch system and sent out of the distribution center.
Quick question, Shema. What do the orange lights? What do the orange lights mean on the? I'm assuming on the batteries.
The orange lights. These are battery compartments that are empty. They do not have any batteries in them. That is why. All right. Any other questions before we go ahead? Okay. So what we're seeing right now is a flight operator who is about to send a package to a health facility. What we did was to assemble the various components of the drones, and we call them line replaceable units. And one of the perks of this system is that when any component is having a fault, it's easy to replace instead of taking down the whole entire drone and replacing it with another. So this modular system helps us to work very efficiently. We can see that the flight operator is scanning some surfaces on the body, on the wing of the drone. They scan the moving surfaces. These have QR codes. What the software does on the iPhone that is used to scan is to make sure that the drone can perform the final pre-flight checks to make sure that everything is working before it leaves. The
So
next
there was
thing
one question. Oh,
all
please
right, sure.
continue.
No, go ahead, Vasu.
So the question is, at what altitude are the drops conducted, the package drops?
Again, please.
At what altitude are the package drops conducted?
Oh, okay. Let me just go into when the drones are in maximum flights, they are about 120 meters, and then they drop to about 25 meters when the package is about to drop. Yeah. Okay, so the final thing that happens is that the flight controller, the flight operator, sorry, communicates with the controller. And what the controller does is to communicate with the air traffic control to give us clearance before we fly out of the distribution center. So when that is done, we're given the green light to leave the distribution center. So you're going to see how the launch is done shortly. Yeah. All right, that's how the drones leave the distribution center. I'm sure there's another question before we go ahead into how, yeah.
That was cool.
Are the operators, it never gets old. It never gets old to see that. I've seen probably like 100 of them now. Are the operators of the drones licensed pilots? That's the question.
Okay, so we have a pilot on the team, but the operators we have, most of the operators we have are just engineers. Some are aerospace engineers. We have mechanical engineers, civil engineers amongst us. Yeah, those are the fields that we have here at the distribution center. Yeah, any other questions, please? Okay, so a bit into the system here. This is the launcher system that actually sends out the drone from the distribution center. It helps it accelerate from 0 to 100 kilometers per hour. And the whole idea of, and it's powered by motors, very strong electrical motors. The whole idea of the system is that we want to make sure that the drone uses very little of its own battery power to accelerate to the cruising speed that it needs, so that the battery power that is in the drone can be used for maximum flights. That is how why the launcher system does the acceleration for the drone. The next thing that we need to take note of is the recovery system that we have here. What the recovery system does is to recover the drone from mid-air when it gets to the facility. As I mentioned, drones don't land. When they get to the health facilities, they reduce in altitude and the package falls gently. So when they get to the distribution center as well, this system has been designed to capture the drone from mid-air when it gets to the distribution center. The recovery system has two black poles, as you can see, and in between these two black poles, we have like a rope or a thread, and this is actually what the capture line that actually captures the tail hook of the drone. We are going to see how the tail hook looks like shortly, so we see how precise this entire process is and the precision that it goes with. The drone communicates with the recovery system using a connection called the line of sight. So this sends about like 20 messages per second to the recovery system and makes sure that the recovery system is prepared for the recovery. So we're going to see how the recovery system prepares itself when the communication is achieved or complete, when the drone is very close to the distribution center. So just notice how the poles react when that communication is complete. Okay, so that's what I was talking about. So with the direction of the recovery system, you notice that the drone is going to recover from the right direction. So we're going to see the recovery soon. We have a nice sunset here. The drone is approaching the recovery system. Okay, here it comes. Okay. All right. We see this all the time, but every time we see it, it's still very exciting. All right.
It's so cool. Shamal, is it
Yeah.
a good time for a couple of questions? There are a few
Yeah.
questions. Is it a good
Sure.
time?
Sure.
Okay.
Yeah. Sure.
So, first question, how long does it take to charge a battery?
Okay. So this question is subjective because depending on the distance that the drone travels, the battery charging time is different. So we have facilities about 15 minutes away, 20 minutes away, and definitely they are not going to use the entire battery power. So depending on the distance, the charging time varies. Yeah, exactly. Depending on the distance that the drone has traveled. Okay.
Great. Next question is, how many can you launch in an hour? And then there was another part, which is, does the launch team also recover? And as you've seen, yes, the launch and recovery happen very much in the same place. But yeah, how many per hour, roughly?
Okay, so we are able to do the whole pre-flight checks and the launch in about 2 minutes and a few seconds. Sometimes you go as low as a minute and 50 something minutes. So doing the math, we can do quite a lot of launches in an yeah. So an average of like one launch every 2 minutes can be done. Yeah.
So the next question is, if you need air traffic control to launch, what class airspace is the distribution center in? And really, what class airspace do we operate in Ghana?
Okay, I personally don't know about those bits. I could find out from maybe Vasu has an idea about how. Yeah, so you can go ahead.
So it depends. It depends a lot from country to country what our airspace agreement is. I actually myself, I'm not super familiar with the classes of airspace in Ghana, but we're still sort of in discussions with, for example, the FAA about the airspace class that we'll be allowed to operate in the US. And so this is definitely something that we sort of negotiate and decide country to country. But yeah, if you're really interested in learning more about that airspace, we can definitely follow up. I also do not know exactly what class airspace we are in Ghanaian airspace.
All right. Any other questions?
Yes. Have you had to abort a mission due to a slinging system mishap? So I think that this means the recovery system. I guess, have we had to abort missions due to the launcher or recovery failing? And what redundancies do we have to reduce errors in takeoff and landing?
All right. So obviously, like when the recovery system is malfunctioning, we can launch. But after the launch is successful, and maybe we have an issue with the recovery system, just as I mentioned, we have two forms of landing. We have the primary and the secondary. The primary is where we use the recovery system, and the secondary is what we spoke about the safety feature that allows us to land using the parachute. So we can use both or any of these two landing systems. So when we have an issue with the recovery system, we can explore the secondary, which is the parachute landing. Yeah.
Great. Okay, next question. What happens if the package does not release, but everything else works properly?
Okay, that's quite tricky. We are yet to experience that. We are yet to experience something like that, but all the time the package drops. What could happen is we have something we call fail upon maximum attempt, fail to deliver upon maximum attempt. This could be due to like maybe wind or environmental conditions like wind when it get the drone gets to the health facility. So it tries quite some number of times to deliver, and when that delivery is not successful, it just turns around and comes to the distribution center. So there are instances where that happens, but it's like 1 in every like 900 or 1,000 flights. It really happens. Yeah. Okay. Any
Okay,
more
one
questions?
more question. Last question. I think, what speed is the Catapult launching at? And what speed is the recovery system catching at?
What speed is the launch one?
What speed does the launcher accelerate us to, and what speed is the recovery system catching the zip at?
Oh, okay. So the launcher system actually accelerates to 100 kilometer per hour, and for recovery, it goes very low to about 10 or 20. Yeah.
Yeah, so it catches, the recovery system still catches the zip and then decelerates it massively.
Exactly.
But what is the maximum speed at which the recovery system can catch the zip? It's still 100 kilometers an hour, right?
Yes, exactly.
Are you ready for one more question?
Yeah, shoot.
If repair, these are great questions, by the way. If repair is needed, what methods of repair do you use? So I'm assuming this is about zip maintenance and ground system maintenance.
Oh, okay. So at the distribution center level, we have a checklist that we do every morning. That's an opening checklist to make sure like every system is functioning, to make sure that the system, whether it's the launcher system or recovery system, is working effectively. So this is done like every morning. However, we have weekly maintenances that we do on certain parts of the drone as well, and other equipments that we have here at the distribution center. And there are some monthly maintenances that we do also at for certain parts of the equipment. So it's either, sorry, that was just a recovery. So it's either weekly or monthly or the daily checklist that we do to make sure that all the systems are working well. Yeah.
Awesome. Are all flights automated? Sorry, go ahead.
That was just another great catch.
Yeah.
Yeah. Flawless. Are all flights automated, or is someone overseeing each flight to make sure the drone doesn't veer off course? Do you want to talk about the role of the controller and how they interact with the drone?
Okay. So let me just show the team something that I'm looking at here. So this is the system. This is how we monitor the drones. Let me hold on, please. This is how we monitor the drones from the air. So the drone you're seeing with the black arrow are drones that are returning to the distribution center, and the white arrows are drones that are going to the health facilities that we serve. All these white lines you see on the map are preloaded flight paths that the drone uses when it's going to the facilities. So every facility that we work with, all the 260 plus facilities that we work with in our 85-kilometer radius have been pre-planned, and their routes have been embedded in the battery of the drone. So this is how it looks like. So we can see where the drone is moving from the distribution center when we look at this map. And because the routes are predetermined, there's actually not no room for like veering off the route, because the routes are like pre-planned and preloaded onto the drone's battery. Yeah. Vasu, if you can go a bit into that as well.
Yeah, I'll say a couple of things. So one thing to point out is our batteries are custom, built in-house, and so they serve more than just the purpose of a battery. They're also a file system. So they have a file system rather. So we load a lot of things onto the batteries. That's what Shimao meant when she said the maps are on the battery. And so yeah, so these maps are embedded are stored on that file system and sort of embedded into the logic of the zips. And they're pre-planned and pre-validated, and we clear them with air traffic control. You know, before we release a new map, we clear it with the relevant authorities. The zip can get blown off course, right, as it's flying. We talked about wind, we talked about various actuator failures. And when that happens, the pilot in command does see the little triangular icon veer off course, and then has a variety of commands that they can issue to either tell the zip to turn around and come back if they see weather ahead, or ask the zip to pull its parachute. Yeah, Divya, you want to add anything?
Yeah, sure. I was going to say that all while this is happening, while the controllers are watching, the zip is still doing its own calculations. So it has some bounds on each of these paths for in the vertical direction and the like XY direction. So if it veers off by a certain amount, the zip will automatically deploy its parachute and land. So there's a lot of checks and balances in place.
Yeah.
Yeah, I saw a red arrow. I guess that was probably a zip that was a little off.
I can see it here again. I saw it as well. I probably a mission failure, and this could be due to several reasons. Classic example is what Vasu and Divya spoke about. If it's veered off, or maybe in having an exception there with a battery or any component, it just returns to the nest. It's not here any longer, but when it comes up again, okay, so this is how it looks like. I'm still waiting to see what exceptions are there. I'll show it to the team when it preloads here.
Great.
Right.
One more question is for the battery slash, file storage system, how do we prevent overheating? Is that a concern, overheating of the battery during flight?
Vasu, would you take that?
Yeah, to be honest, I'm a software engineer, so I don't have the full picture here. But we do, overheating the battery is definitely a concern. I can't actually remember it happening very often, but yeah, designing the system such that all of the components are doubly redundant, like multiple, there's multiple redundancy in all of our components. Everything is sort of designed, the electrical design of the system does take into account overheating and components going down. I'll be honest with you, this is not something that I know too much about, but it's absolutely a valid question, and we do design for those sorts of failures. Divya, do you have additional context on specifically overheating of components?
Yeah, sure. There's two things. The first thing is I believe the charging stations have active cooling to prevent overheating while the batteries are charging. Like there's some AC units hooked up to the actual charging stations. And then second is that at our different offices in California, we have environment chambers where we can basically put all of our parts through major stress. We can basically like cool down all of the parts to like minus 50 degrees Celsius, or we can heat it up a lot. And we have these, at the beginning, it started off as a little shed with like different sorts of gadgets in there to create these different environments. But now we have some more mature, nicer looking environment chambers where we can test all of our parts. And this is how the electrical team tests overheating of batteries and all of our other sensors as well.
I think we, the last I heard, we put these zips through, over 1,000, basically 1,000 days of testing in these environmental chambers. And so any failures and any brittleness in the design hopefully is uncovered via testing. Yeah, and I honestly can't really recall the last time I saw a failure due to overheating of the battery or other components. Couple more questions. What kind of microcontroller does Zipline use? Pixhawk, etc. We use a custom controller. It's not Pixhawk. It's built in-house. Someone says, I don't think a battery will overheat at regular predictable power draw. And I think that's absolutely right. I think that as long as we're not drawing more power than we've designed and tested for, we're okay. And so we make sure that that's true. Does the drone fly in a different altitude depending on the direction it's going? Yes, sometimes. So the terrain, depending on the terrain the drone has to fly over, the pre-planned paths might have different altitudes on the outbound and inbound based on the asymmetric climb and descent capabilities. And also sometimes, also sometimes just based on the terrain, based on sort of whether it's easy to plan a route back from the distribution center based on separate from the outbound path. Sorry, I'll say that again. So often the outbound path to the delivery and the inbound path from the delivery will coincide, but it's not unusual for them not to because of the reasons I mentioned. And then one other question is, are more women entering this field in your area than before? I'll answer that from my perspective. I think yes, but there are still not nearly enough. And so anything you as educators can do to change that would be hugely appreciated. And we're happy to help in any way we can. Shimao and Divya, do you want to add to that?
Yeah,
or any of the other questions?
Yeah, I can just add for women entering this field, I think that aerospace and engineering in general is seen as a very like strict, detail-oriented job, but the reality is that the work that we do every day requires a lot of creativity. For example, the work that Vasu and I are doing is completely thinking of a new way of avoiding other aircraft in the airspace, including like our own zips as well as helicopters and things like that. There's a lot of creativity involved, and I'm sure that Shimao can speak to all the creativity that everyone at the distribution centers exercises as well. Most recently, something that I was just incredibly impressed by is that folks at the distribution centers decided to start using sanitary pads as packing materials. So they were able to actually distribute sanitary pads along with the regular medical supplies to hospitals that really needed them. And that's something that like people came up with on their own. And I think that like kind of marketing that creativity aspect of this field will help with getting more women involved.
I hate to do this, but we're going to probably have to move on to the next presentation. But that was a great presentation. Thank you so much for your tour. One question I have, though, is you're planning to open up facilities in the US, is that correct?
Yeah.
Yes, we actually already fly in North Carolina. We have a facility that's operating right now, delivering COVID supplies.